everyone, this is Professor Rathod from the Scholar Academy. So friends, today we are going to discuss very important topic from the organic compounds, that is halogen derivative of alkanes and arenes. So from this topic, today we have to see the method of preparation of alkyl halides. Okay, so in this lesson we will see how will you prepare the alkyl halides. So you know the alkyl groups we can represent it by capital R, and halide means halogens like chlorine, bromine, iodine and fluorines. They can be represented by capital X. Okay, so we have to prepare the alkyl halides. So in that we see the first method from halogenation of alkane. Okay, by using alkane on halogenation we can prepare the alkyl halides. So first of all we see what is mean by halogenation. Okay, you know the halogenation process. The halogenation means the process in which hydrogen atom is replaced by the halogen group. That is the halogenation. You know the halogens, chlorine, bromine, iodine and fluorines. These are the some halogen atoms. So from any alkane, hydrogen atom is substituted by the halogen groups. Then there will be the formation of halogenation reaction. Okay, so here we see how halogenation will be carried out in presence of alkene. So here we see the example. This is an example of ethane, CH3 single bond CH3. So this is a structure of ethane. So this ethane molecules undergoes chlorination. That means here we have to use chlorine, Cl2 group. Okay, so this reaction carried out in presence of sunlight or UV light. Sunlight. Okay, here we just see. So from this ethane, one hydrogen atom is replaced by the chlorine group. Cl2 means Cl single bond Cl. Okay, so from this Cl2 one chlorine is substituted here, and here simply we get CH3 single bond CH2 Cl, and hydrochloric acid is removed as the byproduct, and here we get ethyl chloride. Okay, so in this reaction ethane reacts with chlorine. In presence of sunlight we get ethyl chloride and hydrochloric acid is removed as the byproduct. Very simple reaction mechanism here. CH3 single bond CH3, this is the ethane. From this CH3 one hydrogen atom is removed, and there will be the substitution of chlorine in place of hydrogen atom, and from this hydrogen and remaining chlorine there will be the removal of hydrochloric acid, and simply we get ethyl chloride. Okay, so we see another example of the bromination. If you use using the bromine, CH3 single bond CH3 plus Br2, means bromine group is there. Same way, so from this ethane one hydrogen atom from this ethane is replaced by the bromine group, and here we get the ethyl bromide, CH3CH2 Br plus HBr is the byproduct. Here we get ethyl bromide. Okay, this is the first method. From halogenation of alkane we get the alkyl halides. So now we see the second method, that is addition of hydrogen chloride on alkene. Second method we have to see now. From alkene addition of hydrogen halides. Okay, so here we see from alkene, just we see the example CH2 double bond CH2. This is the structure of ethene. Okay, have we clear this structure? CH2 double bond CH2, that is the ethene. It can react with hydrochloric acid HCl. Okay, by addition of hydrogen halides. Hydrogen halide means halogens. So here we can use the hydrochloric acid. So here, if ethene reacts with hydrochloric acid, so from this HCl, hydrogen atom going to attach to this CH2 group. CH2 gets converted into CH3. This double bond gets converted into single bond, and this chlorine atom going to attach to here, and simply we get CH3, CH2, Cl. We get the ethyl chloride. Okay, so this is a symmetrical alkene. You know the symmetrical and unsymmetrical. Symmetrical means across the carbon-carbon double bond, same alkyl group is there. That is the symmetrical alkene. If you use unsymmetrical alkene, then just we see the example. CH3, CH, double bond, CH2. Okay, this is the propene. 3 carbon atom is here. CH3, CH, double bond, CH2. Structure of propene reacts with, we can use another hydrogen halides. Here we can use the HBr, hydrogen bromide. Okay, so here we just see how addition reaction takes place in case of the unsymmetrical alkene. Okay, this is unsymmetrical alkene. Why it is called as unsymmetrical alkene? Because from this carbon-carbon double bond, here CH2 group is there and here CH3CH. That means there will be the unsymmetry, not the symmetrical alkyl group across the carbon-carbon double bond on the both sides. If same group is there, that is a symmetric. For example, ethene. From this CH2 double bond CH2, from this double bond both sides CH2 group is there. That is, it is a symmetrical alkene and unsymmetrical alkene. But in case of the unsymmetrical alkene, we can see how HBr will be added. Okay, so here we see one important rule, that is the Markownikoffs rule. Okay, Markownikoffs rule. So according to the Markownikoff rules, what is the Markownikoff rules? First of all, we see Markownikoff rules. Okay, so Markownikoff rule states that for any unsymmetrical reagents will get added to the unsymmetrical alkene, which carry the negative part of that reagent will get attached to the unsymmetrical alkene, which carry the less number of hydrogen atoms. Once again I repeat Markownikoffs rules. So Markownikoff rule states that from any unsymmetrical reagent, this is the reagent HBr, hydrogen bromide, because hydrogen having the plus charge and bromine having the negative charge. So that's why this is the unsymmetrical reagents, that is the hydrogen bromides. So here, so from this unsymmetrical reagent, the negative part means bromine. So this bromine will get attached to the unsymmetrical alkene. Unsymmetrical alkene, this one propene. So that unsymmetrical alkene which carry the less number of hydrogen atom. Where is the less number? This CH group. That means this bromine going to attach to here. Okay, and hydrogen going to attach to the CH2. And simply here we get CH3, CH, Br, CH3. So this is a isopropyl bromide. Isopropyl bromide, or IUPAC name, we can give the IUPAC name. 1, 2, 3, 3 carbon is there, and second carbon containing the bromine group, 2-bromopropane. 2-bromopropane, this is the IUPAC name. Okay, are you clear how isopropyl bromide we get from the propane? This question can be asked for NEET as well as JEE. How will you prepare this isopropyl bromide? by using the propene. Okay, so according here Markownikoff rules will be followed. I have to clear the Markownikoff rules. Markownikoff rules, once again I repeat. So in case of the Markownikoff rules, the unsymmetrical reagents, the negative part of the unsymmetrical reagent will get attached to the unsymmetrical alkene which carry the less number of hydrogen atom, and here we get isopropyl bromide. This is the Markownikoff rules. So what is the anti-Markownikoff rules? If you see same reaction, CS3 CH double bond CH2, if same reagent we can use here HBr, but here we can use the peroxide. In presence of peroxide this reaction will be carried out. Then here follow the anti-Markownikoff rules, that is opposite to the Markownikoff rules. Anti-Markownikoffs rule. Okay, so anti-Markownikoff rules, that is exactly opposite to the Markownikoff rules. So here the negative part of the reagents will get attached to the unsymmetrical alkene which carry the more number of hydrogen atom. That means this bromine going to attach to the CH2 and hydrogen going to attach to here. Then what product we get here? CS3 CH2 CH2 Br. That means 1 bromopropane we get here. 1 bromopropane. 1 bromopropane. So this is the anti-Markownikoff rules, which is exactly opposite to the Markownikoff rules. Okay, so now we see third method from alcohols. We can prepare the alkyl halides by using alcohols. So this is also very simple methods where we can prepare the alkyl halides. So third method is from alcohols. So you know the structure of alcohol which contain the hydroxy group. Okay, so here we can use CS3 CH2 OH. Ethyl alcohol, this is the structure of ethyl alcohol. Okay, so this reaction carried out in presence of HCl. We can heat in presence of ZnCl2, zinc chloride. Okay, if particular reagent we can use HCl and ZnCl2, this is called as a Lucas reagent. You can remember this, Lucas reagent. Okay, if you use HCl and ZnCl2, that combination is there, that is the Lucas reagent. Okay, you can remember that concept in your mind. Okay, so here we see in case of the primary alcohol, this is a primary alcohol. Okay, reacts with hydrochloric acid. Ethyl alcohol reacts with HCl on heating in presence of zinc chloride, ZnCl2. So what product here we get? So from this reaction, from this ethyl alcohol, OH group is removed, and from this hydrochloric acid, hydrogen is removed, and there will be the removal of H2O, and this chlorine is going to attach to here. That means simply we get CS3 CH2 Cl plus H2O. Water molecule will be removed, and here we get the ethyl chloride. Okay, simply here we get the ethyl chloride. Okay, if you use the secondary alcohol, you can take another example, CS3 CHOH CS3. This is the structure of isopropyl alcohol or secondary alcohol. Same reaction we can carry out in presence of HCl. We can use ZnCl2. This is a Lucas reagent. Same way. So here this OH group and this H means H2 will be removed, and this chlorine going to be attached to the in place of OH group. Okay, so here we get CS3 CHCl CS3, and water molecule will be removed. Here we get 2-chloropropane. propane. Okay, I hope you clear this reaction. 1, 2, 3, 2 propane to OL. This is the structure of propane to OL or isopropyl alcohol reacts with hydrochloric acid in presence of zinc chloride. So there will be the removal of water molecule and we get the 2-chloropropane. So this is the method of preparation of alkyl halides. So next lecture we will see the different chemical reaction of halogen derivative of alkanes.